What is sound? You know, I think the best way to learn about something is to do some experiments. So come on, let's find out what sound is together. Sound is caused by vibrations, like when I take this tuning fork and strike it. Do you hear that noise? The tuning fork is vibrating back and forth hundreds of times a second. That causes the air to vibrate, and those vibrations travel to my ear, and my brain picks that up as sound. Sometimes we use the word frequency to refer to how fast a sound is vibrating. If a sound is vibrating really fast like this, we say it has a high frequency. If a sound is vibrating really slowly like this, then we say the sound has a low frequency. Now, sound vibrations travel through the air as waves. We can study these sound wave vibrations using these special pipes over here. To do so, I'm going to heat a small screen located on the inside of the pipe. When this happens, it causes air to rush through the pipe, and the air starts to vibrate. With this small pipe, the air vibrates really quickly, and that causes a high pitch. It should make sense that a short tube like this one produces short sound wavelengths. Let's see what happens if we do the same thing with this long tube here. Once again, when I heat the screen on the inside, air is going to start to rush through the tube, and the air is going to vibrate. In this case, the vibrations will occur very slowly, and that causes a low pitch. I bet you guessed that this long pipe produces long sound wavelengths. When we make sound with our voices, it works a lot like these pipes. Air rushes over our vocal cords and the air starts to vibrate. It's kind of fun to see how gases other than air make our voices sound. Let's try helium. Helium is a gas that's less dense than air.
When helium passes over our vocal cords, it's really easy to move the helium over the vocal cords. So our vocal cords vibrate really fast.
That causes fast vibrations and high pitches. Now we're going to try sulfur hexafluoride. Sulfur hexafluoride is a gas that's more dense than air.
It's really difficult to push sulfur hexafluoride over my vocal cords. As a result, my vocal cords vibrate really slowly, and that causes low pitches. Ha 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 ha!
The Rubens tube helps us to connect all of these ideas about sound: pitch, frequency, and wavelength. We see that a high pitch causes short wavelengths, and of course a high pitch is high frequency. We also see that a low pitch causes a long wavelength, and that's due to a low frequency. Now I think it's really fun to send a bunch of different frequencies through the Rubens tube. Let's try that. Whoa, wasn't that cool?